So let's take a look at graphing parametric equations and eliminating the parameter. So when we're asked to graph x equals t squared minus 2t and y equals t plus 1, notice how x and y, the x and y equations, are in terms of t. So when we graph these, it's best to set up a table or a chart. So I have 3 columns. So my first one will be the t column, and then I can have the x and y. And so you basically first start with any t value you pick, and normally I just start with 0. So if I choose 0 for t, my x value, or my x coordinate, will just be whatever I plug in for t in the x function. So if I plug in 0, then x will equal 0 squared, which is 0, minus 2 times 0. So then we just get x as 0. And then if I plug in 0 for the y equation, then I'll get y equals 0 plus 1, which is 1. So my y will be 1 and my x will be 0. So let's say instead of 0, I pick my t to be 1. So when t equals 1, then I just plug it into my x equation to find the x coordinate. So x will equal 1 squared, which is 1, minus 2 times 1, which is 2. So then x will equal negative 1. And y is going to equal 1 plus 1, which is 2. And so forth. So let's plug in 2. So then x will equal 2 squared, which is 4, minus 2 times 2, which is 4. So then I get 0. And then when I get y, or when I plug in 2 for y, I'll get 2 plus 1, which is 3. So then my y will be 3. So then continuing on, if I plug in 3 for t, then I'll get x equals 3 squared, which is 9, minus 3 times 2 is 6, and that'll be 3. And then for y, I'll get 3 plus 1, which is 4. And let's just do one more. Let's plug in 4 for t. So at t equals 4, x is going to be 4 squared, which is 16, minus 2 times 4, which is 8. And I'll get 8 for x as the x coordinate. And then for y, I'll obviously get 4 plus 1. So that would be 5. So when I go ahead and graph this parametric equation, I'm just going to use the x and y and graph them as coordinates. I don't have to worry about t right now. I'll come back to that later, but we're just going to graph it as the x and y coordinate. So we have 0, 1, negative 1, 2, 0, 3, 3, 4, and then finally 8, 5. So something like this. And then I can just go ahead and draw the lines here, or draw the curve. Now obviously if I were to complete this graph, and I didn't do this, but if you were to plug in negative t values, so like negative 1, negative 2, then the graph would extend this way, and it'll look something like a sideways parabola. And as t is increasing, it is following the arrows. So we're going up and out to the right. So now what we can do is label our t values. So at t equals 0, we have the coordinates 0, 1. So this is 0, 1. So here, this is where we're at t equals 0. T equals 1 is at this point. Right here is t equals 2, t equals 3, or 4, t equals 4. And this is especially helpful for whenever we're talking about like particle motion or speed, velocity, and position functions. So now let's say we are asked to eliminate the parameter. So we're given the parametric function or parametric equations x equals t squared minus 3t and y equals t minus 1. And so what eliminating the parameter means basically is to get rid of t and to put everything in terms of x and y. So in order to do this, you need to change one of these equations, either one of these equations, so that you isolate t, and then what you can do is plug it into the other equation, and that will get rid of t. In this set of equations, it is easier to isolate t in the y equation, because all I can do, so if y is equal to t minus 1, I can just add 1, so then t is going to be equal to y plus 1. So now what I can do is take what I've found for t and substitute that in to the x function and then into the t variables. So I can do x equals t squared, and t is equal to y plus 1. So we can do y plus 1 squared minus 3 times t, which is once again equal to y plus 1. Now it doesn't matter, you can have it either as y equals or x equals. You just need to be able to eliminate t, and that's all that matters. So this is one correct way to eliminate the parameter. I'm trying to eliminate the parameter for x equals t squared plus 1 and y equals 2t minus 1. So both of these you can pretty easily isolate t in, but let's just, since we did y last time, let's just do x. So if I were to eliminate the parameter, if x is going to be equal to t squared plus 1, then t squared, I can just subtract the 1 over, it's going to equal to x minus 1. So then t is going to equal, we can take the square root, and remember it's going to be plus or minus the square root of x minus 1, since we had to take the square root of it. So now that I've found t, I can plug that in to my y equation. So then y is going to equal to 2 times what I found for t, so plus or minus the square root of x minus 1 minus 1, and that is the final answer.